All right, so I believe this is recording. Let's take a look at these two problems. We're solving absolute value inequalities. Um, we see in problem 3, the arrow is pointing away from the absolute value, and in problem 4, it's pointing towards the absolute value. Those are going to be different cases. All right, so if we look at number 3, pointing away from it, we've got two things to do. This splits into two inequalities. We um, change the sign inside the parentheses here. No, excuse me. We change the direction of the arrow and the sign. We drop the absolute value, change the direction of the arrow, and change the sign of the number. Or we simply drop the absolute value symbols and keep everything else the same. Now, that's going to shade our tail region, away from the middle, away from the origin. Let's see if that's what our solution set looks like. So here with this inequality, let's divide both sides by a positive 5. So we have x is strictly less than negative 10. And over here, if we divide by 5, we've got x is strictly greater than positive 10. So let's make a quick sketch on our number line just to visualize what we have here. We've got negative 10 and positive 10, and these are going to be hollow dots and not solid because we have strict inequalities. We are not including these endpoints. Values of x that are strictly less than negative 10 are to the left of negative 10. Values of x that are bigger than 10, we shade to the right. So here we have a picture of our solution set. It makes sense that it's shaded away from the center. If you plug in 0, 5 times 0 is 0. Absolute value of 0 is 0. 0 is not greater than 50. So we're glad that these middle numbers are not shaded. So now that we have a picture of this of our solution set, let's write this solution set using interval notation. The left arrow is shaded. That's a negative infinity. And then we're coming up to negative 10. Negative 10 is excluded, so it's a parenthesis, not a bracket. Then we have a jump, so we have a union. And then positive 10, that's a parenthesis because the endpoint is not included. All the way out to the arrow is shaded, and that's positive infinity. So here's our solution set for problem number 3. Now let's take a look at problem number 4. The first thing we want to do in problem number 4 is isolate the absolute value. So we need to divide both sides of this inequality by positive 10. So we get the absolute value of x is less than or equal to, well, 30 divided by 10 is 3. So now when I have the absolute value pointing towards the variable, I'm going to be shaded in the middle, not in the tails like in problem number 3. So I change the sign. I change the positive 3 to a negative 3 and drop the absolute value symbols and keep the arrow still pointing towards the variable. And so here's our answer if we make a quick picture of our solution set. To determine whether to keep these hollow like we did in problem 3, they were hollow because there was a strict inequality. But here in number 4, it's less than or equal to. So these values are shaded, not hollow. And this time we shade in between here, in the middle. Okay, so a number in the shaded region is going to make this a true statement. Suppose you picked 0 because that's easy to do arithmetic on. The absolute value of 0 is 0, and 10 times 0 is 0, and 0 is less than or equal to 30. Pick some number that's outside of our answer, something like 4. The absolute value of 4 is 4. 10 times 4 is 40. 40 is not less than or equal to 30, so we're glad that's not in our shaded region. So our solution set written in interval notation is we include the endpoints from negative 3 to positive 3, and we have brackets on both of those. So hey, I hope that helps, and I will talk to you later. If you have any questions, make sure that you ask. Bye.